Hey everybody, I'm here to discuss another scientific paper with you all, and I thought what better paper to discuss than my own, right? So I was a research assistant at SUNY Buffalo State in 2016 to 2018. We conducted our field research, and then I finished up my writing in 2019. So it only took me 4 years to complete my master's, which is only double the normal amount of time. So congratulations, Chelsea. So I was studying northern map turtles in the upper Niagara River, and I've talked to most of you about my research, but I have very rarely talked about my conclusions, so I thought that I would take this opportunity to do that. We were studying the movements and behaviors of resident and translocated turtles, northern map turtles, scientific name Graptomus geographica, in the upper Niagara River. Another portion of the project involved looking at the use of artificial nesting and basking platforms, but I probably won't have time to touch on that today. So first, our methods. So we were in the upper Niagara River, and I just wanted to give you a little bit of a background on the geography of the Niagara River because it's awesome. It's my favorite river. I'm a little bit biased because I grew up there, but so the Niagara River connects two Great Lakes. This is Lake Erie down here and Lake Ontario. And fun fact, when a river connects two lakes, it's actually considered a strait. So Lake Erie funnels into the headwaters of the Niagara. It flows north, splits around Grand Island, meets back up, reaches Niagara Falls where it drops in elevation, and then continues on as the lower Niagara until it reaches Lake Ontario. So a few really interesting things about the river. First, it flows north. And so most rivers in North America flow south. And it's kind of counterintuitive when we're talking about animal movements or flow of the river, because when I'm saying upriver or against the current, we're actually talking about south on a map. So a little bit weird. Something else to mention, this is Buffalo, New York right here. And so this is the United States shoreline, but this is the Canadian shoreline. And for my research, I didn't have to deal much with that collaboration between the two countries other than alerting Border Patrol when we were tracking individuals on this shoreline. But when we're talking about fisheries management or talking about Lake Erie as a natural resource, these two countries are having to work together to manage that resource. So just something interesting to think about. So this is where I was studying northern map turtles, and we were using a method called telemetry to track individuals. And telemetry works in a similar way to your car radio. So we put little transmitters on animals, and you can use this for all types of wildlife. You put a little transmitter on an animal, and it is transmitting radio waves at a certain frequency. And the researcher has an antenna and a receiver, kind of like your car, and you are picking up this transmission, and depending on which frequency you're picking up, you know which individual it is. So each individual has their unique frequency on their transmitter. And then once you find the animal, you are recording their GPS coordinates, their behavior if you see them, different habitat indices, and then later on you can analyze all this information to figure out what's going on with them. And so a few things that I wanted to talk about that I found after doing this in the upper Niagara River. So first, northern map turtles in the upper are potentially, it's potentially a sink habitat. And so what a sink population, so what a sink is where individuals are moving in from a different location and then not reproducing. So one of the ways that you can figure this out is by doing nest surveys. And if you're not finding nests, then they're probably not nesting. And then also by not finding hatchlings, right? So if a population was reproducing, you would be finding their little babies somewhere. And in the 5 years that these turtles were studied, there were no hatchlings found. So they may be using different habitat as a nursery, and that's something to consider in the future. but for our project, we were not finding hatchlings. It was suspected to be a sink population. On the other side of that, you would have a source population, so that would be the opposite of a sink, where animals are reproducing, providing a source of individuals to that population. So the first figure that I wanted to show you is the combined home range of translocated northern map turtles in the upper Niagara River. So we tracked resident individuals that were captured in the river, and then we also tracked translocated individuals that were brought in from Lake Erie. Now typically, when you're comparing the movements between resident and translocated animals, you are trying to determine if the translocated animals are exhibiting homing behavior. So when an animal gets moved from a certain location, especially turtles, they often try to get back to that location. And that is what I found. So one of my conclusions was that translocated turtles were exhibiting homing behavior. So this is a map of translocated movements, or a combined home range. So you can see those yellow lines are where translocated turtles, the paths of translocated turtles. Now, something interesting to point out is that translocated turtles used the Canadian shoreline. So you can see that they were along the Canadian shoreline. They were trying to use these tributaries or streams. And now my hypothesis for that was that they were trying to move in the direction of their original location. So let me show you this figure. The Niagara River is at an orientation like this, but the translocated turtles were captured initially here and moved into the river. So you would suspect that their movements would try to be in this direction, and that is what I found. So if they were using tributaries on the Canadian shoreline, they were trying to move in this direction. And the other interesting thing about that is that residents were never found on the Canadian shoreline. So again, in 5 years of tracking residents, they were never found over there. So I also mentioned that this habitat is potentially a sink. And so what I was finding was that translocated individuals were trying to move upriver, but this is at the headwaters of the river, and I'll zoom out so that you can get a better idea of where this is. But this is a map of the farthest location south that animals were located. And you can see here that they can use the shoreline, and they're protected from the current by these little outcroppings or whatever, these cement walls. But then they're in the direct flow of the Niagara River. So Lake Erie is right here feeding into the river. And for those of you familiar with the area, this is the Peace Bridge right here. So this current is fast, and turtles were unable to swim or crawl upriver. So once they reached these locations, the very next day they were found all the way downriver. And so I hypothesized that they were being swept in. Now this is important because if an animal is trying to get back to where they came from, then they're just going to keep trying to do that. And in this habitat, what happens is they are funneled into a specific habitat. So let me show you. So that last location that I just showed you is right here. You can see that yellow line stops right there. Now, I said that those were the furthest locations south in the river, but animals are able to use this Black Rock Canal opportunistically when the lock is open. So there's a lock right here, and if that lock is open, animals are able to move through and get up to Lake Erie using the canal. But if it's not, then they're trapped in that habitat and not able to make it back up to Lake Erie. So that was one of my management conclusions, is that maybe with better lock management, maybe if one side is left open, then animals are able to move through more freely. But then we also have to consider invasives. But because the Niagara River is parallel to it and they're coming in from Lake Erie anyway, it's kind of irrelevant in that scenario. but in other locations, that is something that would be considered. And then the last thing that I wanted to show you is a graph of translocated and resident turtle movements over the course of 2 years. So along the x-axis here, or the horizontal axis, is time of year, or Julian date. And then along the y is cumulative distance moved. So I was calculating daily distances moved by individuals. And how you do this is if there are 2 known locations, so say Saturday, I tracked this female here, recorded her GPS coordinates. Sunday, she was here, so I recorded those GPS coordinates. And how you would find daily distance moved is finding the difference between those 2 locations and then dividing it by the amount of time between those records. So in that case, it would be 1 day. And so she would have moved this far per day. Now, this graph is taking those daily distances moved and having them accumulate throughout the year. And what it's showing you is there's these red lines are resident turtles and the blue are translocated. And so you can see how much farther the translocated turtles moved within the year. Something else that this graph is telling, so if you look at the slope of the line, you can see that the blue lines are much steeper than the red. Now what this means is that in a very short amount of time on the x, let me hold this, there would be a really large movement along the y. And so that would mean that when this slope is super high, that daily distance moved, so within a really short amount of time, it could be a day or 2 days, they moved that much on the y. And then you can see that these movements, these really large movements, are happening in the fall, and then they plateau. And so some of you who know turtle biology would maybe recognize this behavior. For those of you who don't, turtles remain inactive during the winter. And so this represents their movement to find hibernacula, which is their overwintering site. And then these plateaus are showing them being inactive during the winter. So yeah, so the conclusion from that is that translocated turtles moved a lot farther than resident turtles and explored a lot more of the river. Whether they were looking for suitable habitat or whether they were trying to get home is kind of left up to interpretation. But overall, my research suggested that the upper Niagara River is potentially a sink. However, there are tributaries along the shorelines of America and Canada that turtles are able to use. So maybe future research should look at surveying, Ellicott Creek or Erie Canal or Buffalo River, Scajaquada Creek, all of these different tributaries for populations of aquatic turtle species. Again, I wrote 140 pages, so if you have any questions, you can contact me or read it yourself for 3 weeks. I don't know how long that would take you. But yeah, thanks.